boys and girls, it's Miss Bissell. I am on topic 1, lesson 5, on page 22 of your textbook. You will need your textbook, a pencil, and that is it for today. So if you need to run and get anything, I will wait for you to go get that. All right, so on page 22, we're looking at our essential question, and we want to know, how can you compare decimals? So when we compare decimals, we're looking at their value, and we want to know, when we look at 2 or more decimals, which ones are less than, which ones are greater than, or which ones have the same value and are equal to. So we're going to talk about decimals. I'm going to actually come out of the book for a minute, and I've prepared a sheet of paper I want to use with you, boys and girls. So if you will copy these down. All right, if you want to go ahead and head your paper, comparing decimals, less than, greater than, or equal. And these are the steps we're going to use. We're going to stack the decimals. We're going to use place value holders, or zeros as place value holders. And we are going to then compare using less than, greater than, and equal symbols, looking at those values. Now, you have a page in your journal, and I am at home, and I did not have my journal with me, but I did print the page. So we're going to be using the steps that are in your journal. I want to say it's probably around page 76, 77 in your journal. Okay, this paper right here are the steps we're going to use. We're going to be using it with comparing and ordering decimals. And ordering decimals we're going to be doing on Monday. So if you enjoy today's lesson, you're definitely going to enjoy Monday's lesson. All right, so let's talk about these. 5 1/10 compared to 5 100. Now, we learned in yesterday's lesson that we can create equivalent decimals. So we're going to be doing that when we stack them. So when I look at number 1, I'm going to stack it down here. This is going to be my little workspace. I can write 5 1/10, and I'm going to stack it with 5 100. Graph paper would work probably even better for this to keep everything in straight lines. But what you're going to notice, boys and girls, is that 1/10 has 1 digit behind the decimal point, and 100 has 2. And if you remember yesterday, we learned that we can make an equivalent decimal by putting a 0 behind any decimal digits. So if you think about it, 1/10, so 1 rod would be equivalent to 10 of the little hundredths. Put together, the 10 hundredths fused together would be a rod. Okay, so we could see that with our place value blocks if we had those with us. So 10 hundredths is equivalent to 100th. When you annex this 0 or add it, it helps you then to compare hundredths to hundredths, okay? Now, just like whole number place value comparison, we start in the ones place. They both have the whole number 5. That's not going to help us with the comparison. We move over to the tenths place, and 1/10 is greater than 0/10. So what I know then is that 5 1/10 is going to be greater than 5 100. Now, unlike whole numbers, you can't compare by the number of digits. Look at this. This just has 2 digits in it. This number has 3 digits in it. So with whole numbers, if you had 3 digits, you would know that that would be a larger value. But you cannot go by that with decimal numbers, okay? You really need to create equivalent decimals with the same number of digits behind the decimal point, and then compare column by column, place value by place value. So look at number 2. We have 7/10, and we're going to compare it to 7 hundredths. So just take a second and stack your decimals. So 7/10, 0.07. If you line up the decimal points, that helps get everything else in line. We're going to annex a 0, and we're going to create an equivalent decimal. 7/10 is equivalent to 70 hundredths. All right, we go to compare. We take a look. Zeros are the same. 7/10 versus 0/10. That is going to make this number right here the larger of the 2. 70 hundredths is greater than 7/10. I'm sorry, let me go back. 70 hundredths is greater than 7 hundredths, and 7/10 then would be greater than 7 hundredths. Okay, So we're going to use our greater than sign for 7/10. Okay, 584 thousandths compared to 58 hundredths. So I'm going to line up those decimal points, and then all the place values should line up. I've got 58 hundredths. I'm going to annex a 0, and I'm going to put it right here so we see it. All right. When I look at this, the whole number's the same. 5/10ths are the same. 8 hundredths are the same. We have 4/10ths versus 0/10ths. So guess what, boys, or thousandths. So 584 thousandths is greater than 580 thousandths. Now that is the equivalent decimal for 58 hundredths. So what that means is 584 thousandths is greater than 58 hundredths. All right, number 4, 9 and 327 thousandths versus 9, and 236 thousandths. What I notice here is they both have 3 digits behind the decimal point, so I do not need to add any zeros. The 9 ones are the same. Here I have 3/10ths versus 2/10ths. 3/10ths are larger, so 9 and 327 thousandths will be larger than 9 and 236 thousandths. All right, for some reason, all the ones on the left have been greater than. So let's see what goes. That's just odd. All right, number 5, we have 5 and 2/10ths, and we're going to compare that with 5 and 20 hundredths. So what I notice, I have one digit behind the decimal point versus 2. So I'm going to annex this 0. Here's the 0 I annex. So you can clearly see, boys and girls, this is the same value. 5 and 2/10ths is going to be equivalent to 5 and 20 hundredths. Okay, so we're going to be putting our equal sign here. All right, see, these are pretty fast, but do take the time to write them down and stack them, not just write them, stack them, and then create equivalent decimals with those place value holder zeros. Okay. Hey. All right, so next we have 5 and 643 thousandths compared to 5 and 64 hundredths. We're going to add the 0. That's our place value holder. We created an equivalent decimal. 5 and 65 hundredths is equivalent to 5 and 650 thousandths. Now I'm going to compare place value by place value starting at the largest. The 5 ones are the same. The 6/10ths are the same. We have 4 hundredths versus 5 hundredths. So 5 and 65 hundredths is greater than 5 and 643 thousandths. All right, you should be getting the hang of this by now. All right, we're stacking the decimals, using those place value holders to create the same number of digits behind the decimal point, and then we are comparing place value to place value, left to right, until we find a difference. All right, next we have 100 thousandths versus 100th. All right, I'm going to add a 0. I've already stacked my decimals. This is my place value 0 that I've added. Now I'm going to compare. 0 are the same. 1/10 is greater than 0/10. So without looking any further, I know that 100 thousandths is greater than 100th. And the last one I have on this little practice page is 99 and 1/10. And I'm comparing that to 99 and, I threw a big one here, 314 10 thousandths. Now, I'm going to annex my zeros. So I have 4 digits behind the decimal point. I only have 1 here. So I'm going to annex those 3 zeros, add those place value holders. And really, 99 and 1/10 is equivalent to 99 and 1,000 10 thousandths. When I compare, my 10s are the same, my 1s are the same. When I get over to the tenths place, I have 1/10 versus 0/10. So this one is going to be larger. So 99 and 1/10 is actually greater than 99 and 314 10,000ths. This is a good one to look at to see that it doesn't matter how many digits there are in the whole number. All right. You have to look at the place values. Okay. You can't go by the number of digits like we do with whole numbers. All right. So in our book, we are looking at some do you understand? All right. I'm just going to go right here. I'm not even going to use the visual learning right now because I think this is a pretty easy concept just to teach. All right, scientists measured a Madeira cockroach and found it to be 3 44 centimeters long. Toby says that the Madeira is shorter than the Oriental because 3 44 has fewer digits than 3 432 thousandths. Is he correct? Explain. All right. You guys, we're comparing 3 44 with 3 432 thousandths. And at this point, with the 8 problems that we just did, you should know that we can't go by number of digits. Okay. So in this case, Toby is not correct because if we stack those decimals, and if we put the place value holder 0 to create an equivalent decimal, then what you see is that they don't differ in the ones place, they don't differ in the tenths, they differ in the hundredths place, and 3 44 is actually greater than 3 432 thousandths. So in this case, no, Toby is not correct. Now, just a reminder, you should be filling out the same problems in your book that I am filling out in my book. That way you have good example problems to look back at. All right, so let's make a note. 3 44 has 440 thousandths. Remember when we created that equivalent decimal above? All right, it has 440 thousandths, and 3 432 thousandths has only 432 thousandths. Okay, so 432 thousandths is going to be less than 440 thousandths. Okay, and that goes back to using those 3 quick steps. Okay, now let's take a look at these right here. We have, for number 3, we have 3 692 thousandths compared to 3 697 thousandths. All right, I actually don't feel like I even need to stack this one, because when I look at it, they both have 3 digits behind the decimal point. I can compare side by side. The 3 ones are the same. The 6 tenths are the same. The 9 hundredths are the same. So where my 2 numbers differ are in the thousandths place, and 7 thousandths are greater than 2 thousandths. So take a look at it. Isn't 692 thousandths going to be less than 697 thousandths? All right, the same thing with number 3. We don't even need to annex any zeros, any place value holders. They both have 2 digits behind the decimal point. So let's compare 7 whole numbers, the same in both. 2 tenths is the same, and the differing place value is the hundredths. We have 1 hundredth versus 0 hundredths. So 1 is greater than 0. You can stop right there. So think about it. 216 thousandths is going to be more than 203 thousandths. All right. I love number 4 and 5. We haven't done that yet. We are going to order decimals from least to greatest. Make sure you understand the vocabulary. Least means the smallest value. Greatest means the largest value. Now, I am going to use the same strategy. I'm going to line up these decimals, stack them up. Okay, so when I stack them up, I have 5 and 540 thousandths. All right, I have 5 and 631 thousandths. I have 5 and 625 thousandths. I do not need to add any of the place value zeros. Each number that I am going to be ordering, each number has 3 digits behind the decimal point. So when I put them in order and I want to go least to greatest, so smallest number to largest, so as I'm looking, they all start with a 5 in the ones place. In the tenths place, we have a 5, a 6, and a 6. So right away, I know that 5 and 540 thousandths is the least up there, and I'm comparing and using the tenths place to see that. So I can cross that one off. I like to use this strategy of crossing off, and actually I might as well go ahead and write it on my book. That's the least value. Now, we know that the two numbers left have a 6, the same digit in the tenths place. So we move over to the hundredths and we see 3 hundredths versus 2 hundredths. Well, 2 hundredths is less than 3 hundredths. So I'm looking for the least to greatest value. So I want to use this one next. 5 and 625 thousandths. And I'm going to put a semicolon between those. That comma almost looked like my numbers were running together. That leaves the largest value, the greatest value, as 5 and 631 thousandths. And I'm going to check it. 540, 625, and 631. If those numbers, which are my thousandths, are in order least to greatest, then 5 and 540 thousandths, 5 and 625 thousandths, and 5 and 631 thousandths would be in order least to greatest. So let me write these on my book. Okay, and again, pause me if I'm going too fast and you need to get more clarification on something by listening again. All right, number 5, we're moving these in order from least to greatest. So remember our steps. We're going to stack our numbers, making sure those decimal points are lined up. We have 4 numbers this time. And I noticed something right away. Do you guys notice that one of our numbers only has 2 digits? So I'm going to add a 0, my place value holder 0. 35 hundredths is equivalent to 350 thousandths. There, you can see it a little better right now. So we're going to go least to greatest. Okay. So I'm looking up here and I notice starting in the highest place value, the ones place, I have 2 zeros. So one of these is going to be the smallest value. So I'm only going to focus in on these 2 numbers. They both have 6 tenths. One has 7 hundredths. The other has 9 hundredths. So what I know is this top one, 675 thousandths, has the smallest value. That would mean the next largest would be the 693 thousandths. So I've just used these 2, so cross them out. Now I'm still going least to greatest. So this time I'm going back to the 1 in the ones place. It's the same, so that doesn't help me. I'm moving over to the tenths place, and 3 tenths is less than 5 tenths. So I know that 1 and 350 thousandths, which was originally this 1 and 3,500. So I'm going to write the number as it was originally in the list. That one is the next greater number. And that leaves this last number, 1 and 529 thousandths, to be the largest or the greatest value of my 4 numbers. So to check it, I know that 675 is less than 693. And checking it, I know 1 and 350 thousandths, that 350 thousandths is less than the 529 thousandths. So these are in order least to greatest. All right, pause your video and work these problems at the bottom. Go ahead and work those, and then we're going to come back and talk about them. All right, so hopefully you are done. You've worked them out. Let's talk about these solutions. 890 thousandths is equivalent to 890 thousandths. 5 and 733 thousandths is greater than 5 and 693 thousandths. And I underlined the place value that helped me determine which of these numbers I was looking at to make my final call on the digits or the numbers that had less or greater value. Number 8, 9 and 707 thousandths is less than 9 and 717 thousandths. All right. When you put these in order, you were going greatest to least. So you were doing the opposite of what we were doing with number 4 and 5. You were looking for the largest value and going in order down to the least value. So on number 9, the largest number is 887 and 304 thousandths, followed by 887 and 43 thousandths. And that is followed by 878 and 403 thousandths. Oh my goodness. Look what Miss Purcell just did. I actually making a big deal about going from greatest to least. And I went least to greatest. All right, let me fix that real quick. So, my bad. See, even teachers make mistakes. 878 and 403 thousandths. The next smaller number is 887 and 304 thousandths. I don't even have them right. What is wrong with me? 887 and 43 thousandths. Now, I'm going to check myself because I don't know where my mind was. All right, so I'm looking for the greatest value. The whole numbers are the same in these two. So 878 is less than 887. So the whole number place value right here is what helped me make that determination. And since the whole numbers are the same, I have a 3, which is in the tenths place, which is greater than 0 tenths. So I was looking in the tenths place. I bet I have this one wrong too. Check me. 436 and 565 thousandths. That is not the greatest number. So we are going to go back. Yep. I didn't read carefully. All right. Looking for the greatest value. 435, 436, 435. This one right here, based on the whole numbers, is the greatest. 436,000. 436 and 565 thousandths is the greatest value. Now I'm looking for the next greatest of these two. The 435 whole number is the same. We have 5 tenths versus 6 tenths. 6 tenths is larger, so my next number is going to be 435 and 665 thousandths. And the number with the least value is 430. No, you know what? I am really not with it, guys. Should not be making videos late at night, should I? All right, let me go back. 436, that was the largest number. 436,565. Okay, we took care of that one. We have 435,5, 435,6. Okay, so looking at the tens place, 435 and 665 thousandths would be the next greatest value. And the largest value, looking at the tenths place, would be 400. The least greatest value, 435 and 566 thousandths. All right. Least greatest to least. All right. On the back, there are just a couple problems I want to talk about real quick because you might see something like them in your practice buddy. So flip over to page 24. And let's talk about problem number 12. All right. Carlos wrote 3 numbers between 33 hundredths and 34 thousandths. What number? No, 33 hundredths and 34 hundredths. What numbers could Carlos have written? So we're looking for 3 numbers that could fit between 33 hundredths and 34 hundredths. Now, you're probably thinking that's not possible, but it is if we make equivalent decimals by adding a 0, and now we have 330 thousandths and 340 thousandths. Again, I'm going to use some color just so you see where I added the 0. Now, when I make these 330 to 340 thousandths, then I can slide 10 numbers in between. I can slide 331 thousandths. I can slide 332 thousandths. I can slide 333 thousandths. I can slide 334 thousandths all the way up to 339 thousandths. And I could pick any of those numbers. Put a star there. Look what I did. I changed 33 hundredths and 34 hundredths because I don't have any numbers between those. 33 comes right before 34. But if I made the equivalent fraction decimal 330 thousandths and 340 thousandths, then between 330 and 340 are the digits 331 through 339. Okay? All right. So that is the main one I wanted to look at. So back to our how can you compare decimals? I hope that you're able to answer that you are going to stack the decimals, use the place value holder zeros to create equivalent decimals, and then you are going to compare place value by place value from the largest place value on the left working to the smallest place value on the right. All right, boys and girls, do a good job on your practice buddy, and I will see you soon.